Hello and welcome back to Machine Learning. I'm Javita Christie, and in this video, we are going to talk about the other two clustering methods, which are K-Medoids and hierarchical clustering. So let's begin. Let's first talk about the K-Medoids algorithm. We will take an example for that, and for simplicity, we will be using 8 data points and a 1D data, which means one-dimensional. And these are the points 1, 2, 3, 5, 9, 10, 11, and 25. And clearly the point 25 must be an outlier because it's much higher than all the other points. Okay. And it is going to affect our cluster formation when we perform a k-means clustering, because in k-means clustering, we try to do the clustering based on SSE, which is sum of squared errors, which is the distance of all the points from the centroid. And that is going to get affected by this 25 value, which is an outlier. Okay. If you have k equal to 2, then what are the clusters you can form? You can have one cluster of 1, 2, 3, 6, and another one was 9, 10, 11, 25, because clearly there's a gap between the two, and you can divide them like that. This means if you find the average or mean values for all the clusters, these are the values you get. For 1, 2, 3, 6, it will be 12 by 4, which is 3. And for 9, 10, 12, 25, it will be 56 by 4, which will be 14. Now, if you calculate the SSE, which we use in k-means clustering, you will get this. So for the first group, you have all these data points, right? You have 1, 2, 3, and 6. And you have the mean values 3 everywhere. So 3 is there, subtracted from everywhere, and take a square of that. For the second cluster, the data points are 9, 10, 12, and 25. And the mean is 14. So you subtract 14 from everywhere and take a square of that. And you get 179, which is quite high. Okay. If you compare this with another cluster, so let's create another cluster. This time the cluster is 1, 2, 3, 6, 9, and 10, 11, 25. With this cluster, for the first cluster, the mean is 4.2. For the second cluster, the mean is 15.67. And now if we calculate the SSE, it is going to be lower. Okay, because k-means will tend to put 0.9 in the same cluster with 1, 2, 3, and 6, though the point is logically near to points 10 and 11. Okay, so that is why k-means algorithm has this problem, because it works with SSE. And the skewedness is introduced because there is an outlier 25, which is so far away from all the other points, and it's going to affect the SSE, and it's going to affect the selection of the centroids. So that's why K-Medoids can be used instead of the K-means algorithm. K-Medoids provides you a very simple solution to this, that instead of considering the mean of the data points, you will consider K representative data points from the existing points as the center. So in K-means, we randomly pick our center based on the means, based on the average. But in K-Medoids, we will not pick a hypothetical point. We will try to pick an actual point. So an actual data point from your data set is going to be the center. So that's how we can prevent it from getting affected by the outlier. Okay, and then it assigns the data points according to their distance from these other data points, these 3 points that you have picked to form the clusters. Now here you have to note that the medoids in this case are actual data points or objects from the data set. They are not imaginary points like we selected in the k-means clustering algorithm. Okay, and now if you have to calculate the SSE, you can calculate it like this. So the only difference between this formula and the one that we saw for k-means algorithm is this. So there we have CI, instead of that here we have OI. Okay. Here OI is the representative point or object of a particular cluster CI. So there CI was imaginary and hypothetical, but here OI is actually a point of one of the data points that you have. So K-Medoids algorithm groups n objects in k clusters by minimizing the SSE. And because of the use of medoids from the actual representative data points, KMedoids is less influenced by the outliers which are present in your data. And one of the practical implementations of the KMedoids principle is known as the partitioning around medoids algorithm, which is also known as PAM. So the PAM algorithm is used to implement KMedoids. Let's see what happens in this algorithm. So it has several steps. The first step is to randomly choose k points in the dataset as the initial representative points. Okay, so here also it is random. You have to choose k random points. Then you'll apply this loop where in the first step, you will assign each of the remaining points to the cluster which has the nearest representative point. So this algorithm is very much similar to the k-means clustering. The only difference is that in k-means clustering, we do not select k random points from the dataset itself. We select k random points from anywhere. Okay, they will be somewhere in the middle, but they don't necessarily have to be from the dataset. Whereas here they are from the dataset. Otherwise, the algorithm is the same. So once you have assigned all the remaining points to their clusters, you will randomly select a non-representative point in each cluster. And then you will swap the representative point OJ with OR. Okay, so OR is your non-representative point, and you will compute the new SSE after swapping. So what you have done is initially you picked random representatives. Now you are swapping those random representatives with new representatives that you have picked out randomly, and you will calculate the new SSE. If you find that your SSE now is less than the old SSE, which you had with the previous representative, okay, then once again you will perform this swap of OJ and OR, and you will get new representatives. And you'll go on doing this, go on refining the K clusters till there is no change in the SSE, okay, till your SSE stops getting, till you stop getting a new SSE which is less than the previous one. So you will go on repeating this algorithm in a loop. So that's what the PAM algorithm is. Let's now talk about hierarchical clustering. So in hierarchical clustering, you can group the data into a hierarchy or tree-like structure. For example, in machine learning, we saw this problem earlier about employees and these professors and stuff like that in a university. So you want to group them. You want to group the employees as professors, assistant professors, supervisors, and lab assistants, and etc. So you could do that using the hierarchical clustering because there is a hierarchy here. Okay, it creates a hierarchical cluster of these employees if you visualize it. So there may also be a data set where you want to perform clustering, but it already has an underlying hierarchy. So you could make use of that to perform your clustering. And there are two main algorithms or methods to perform hierarchical clustering. One is the agglomerative clustering, the other one is divisive clustering. In agglomerative clustering, you use a bottom-up technique, which means you consider each object as an individual and then group them into clusters iteratively and go on merging and forming larger clusters till you reach the desired number of clusters. So this is like creating a tree data structure, but starting from the leaves instead of from the root. And the other one is the divisive method, which starts with one big cluster. So it considers that all the data points form one big cluster, and then it goes on splitting and creating more clusters iteratively, smaller clusters, one by one, by hierarchical clustering. The agglomerative method uses the bottom-up strategy, like we saw. It starts with each object forming its own clusters. Then it iteratively merges these clusters according to their similarities and keeps on forming larger clusters. And it will stop when you reach a certain condition. Like maybe you have reached the certain number of clusters that you wanted to create, so then it will stop. And in divisive hierarchical clustering, you have a top-down strategy. So the starting point is one large cluster, which is then recursively split into smaller and smaller clusters based on the dissimilarities between the points. And in the end, you will receive the final number of clusters. So once again, you can stop when you have reached the desired number of clusters. And in both these cases, it is important to remember to select the split and merger points carefully. Okay, so if you are working with divisive method, you have to select the split point very carefully. If you're working with the agglomerative method, you have to select the merger points very carefully, because the subsequent splits or mergers will use the result of the previous ones. So if you make a mistake in selecting them, then the subsequent steps will also get affected by that, and it will result in a poor clustering quality. The type of structure which is normally used for implementing this is known as a dendrogram, okay, which is a step-by-step creation of a hierarchical clustering. And it shows you how the clusters are merged iteratively if it is agglomerative, or split iteratively if it is a divisive clustering, until you reach the optimal clustering solution. This is what a dendrogram looks like. So if you're performing agglomerative clustering, you can see we begin with 5 clusters, and then we go on merging these clusters based on their similarities until we reach this one big cluster. So it moves in this direction. And if you're doing divisive clustering, you will move in this direction. You'll begin with one big cluster. You go on splitting it into different smaller and smaller clusters, and you can get these 5 clusters. So that's divisive clustering. One of the core measures of proximity between clusters is the distance between them. There can be many ways to measure if certain points belong to a certain cluster. The most common one is to just measure the distance. Okay, and there are 4 ways, standard methods to measure the distances, and we're going to see those formulas here. But in the formula, remember Ci and Cj are 2 clusters with Ni and Nj respectively. Okay, and Pi and Pj represent the points in these clusters Ci and Cj. And we will also denote the mean of the cluster Ci as Mi. So let's take a look at the formulas. You can calculate these values. You can calculate d min, which is the minimum distance between Ci and Cj, by subtracting all the points of Ci and Cj from each other. You can calculate maximum distance between 2 clusters by applying this formula. You can also calculate the mean of 2 clusters like this, and the average distance also in this manner using this formula. Okay, now often the distance measured is also used when you want to terminate the clustering algorithm, right? So once you've reached a certain number of clusters, you don't want to proceed, you want to terminate the algorithm. For example, if it is an agglomerative clustering, you could stop your merging if you have reached some minimum distance between 2 neighboring clusters, right? Because you're going on merging and now you have certain number of clusters you want to stop. You can stop if the min distance between 2 clusters becomes very much less than whatever was decided by the user as a threshold value. And so when an algorithm uses the dmin measure, then it is referred to as the nearest neighbor clustering algorithm. Okay, when you calculate distance using dmin, it is the nearest neighbor clustering algorithm. And uh, if you base your decision to stop on the user-defined limit on dmin, then it is known as a single linkage algorithm. So you will stop the agglomerative method once you reach a certain limit of dmin, which was defined by the user. Such an algorithm is called a single linkage algorithm. Now, on the other hand, if you use the dmax measure to measure the distance between clusters, then it is known as the furthest neighbor clustering algorithm. And you will stop when you reach a certain value of dmax, which is defined by the user. And this will be called a complete linkage algorithm. Now, as this minimum and maximum measures, they provide you two extreme options to measure distance. They are also more prone to outliers and noisy data. Okay, so to avoid that, you could also use the mean and average distance so that the outliers do not affect your clustering process too much. So that's it for this video. I'll see you in the next one. Thank you for watching.